how to calculate the effect size measure R squared in a multi-level model or linear mixed effects model with R. If you run a statistical model, you would like to report an effect size measure. For regression type analyses, one of the key effect size measures is R squared, that is, the explained variance. In an ordinary regression, it's simple to calculate that measure. You divide the explained variance by the total variance. In a multi-level model or linear mixed effects model or hierarchical linear model, it's a little bit more complicated, because there are several different layers of possible explanations for variance. So there is no consensus in the literature on how to calculate R squared, and it's not very easy to calculate. For that, there is a package, R2MLM, which helps you to calculate R square values, and actually different R square values. First, of course, we need to estimate our model. In this tutorial, I'll work with the nlme package, but the R2MLM package works also with multi-level models based on the nlme package. So you can use both standard multi-level packages with this approach. As an example, I use an inbuilt dataset in nlme, sleep study, which can be used to investigate the effect of sleep deprivation on reaction time. First I do some data cleaning that's not relevant for this topic, and then I estimate the multi-level model. LMER function, reaction time is predicted by the intercept and days, so we have a fixed slope, and here the random effects, random intercept, and a random slope for days. Here we have our results, the random effects, the fixed effects, but what we don't have is R squared. For that we can use the R2MLM function from the package with the same name, based on the result of the multi-level model. As an output we get a figure and we get numbers. Let's start on the right with a graphical representation. The total variance of the dependent variable is decomposed in this example into 4 groups. Down here, that's the variance explained by the fixed slopes. And one possible approach to reporting R squared in a multi-level model would be to say, yes, that is our R squared. Then, this part, that slope variation, that is the variance that is associated with a random slope. That is, with the fact that the slope is different in different level 2 units, and in this example, in different persons. The third component, and here the largest, that's the intercept variation, or random intercept. That is the variance in the dependent variable, here in the reaction time, that is due to average differences between persons. And finally, there is the residual variance, that is the variance that is not explained. Here you can find the numbers that go into the graph, and here we get different possible R squared values. One possibility would be to just report the value in the row F, that is the variance explained by the fixed slopes. Another possibility would be to report one of those two combinations here. FV would be fixed slopes plus random slopes, and FVM would be fixed slopes, random slopes, and random intercept. It's up to you to decide. I think you should look at the literature in your area of research, what is common there. What I would do, and I think the best option, is reporting these 3 lines. So not just one R squared value, but at least these 3 values. Because then the reader knows this much is explained by the fixed slopes, this much by the random slopes, and this much by the random intercept. I think this gives the most complete overview about the effects in this multi-level model. If you want to learn more about different ways to calculate R squared and about this function, this here is a journal article by the authors of this R package. Thanks for watching, and see you in the next video.